So the word dimensional analysis really is just a fancy way to say that we are going to make a conversion or change between different units of measurement. And the way we do that is we use a conversion factor. So if I asked you to convert, 31 years to seconds, pretty confident that most of you'd be able to do that fairly easily because you know how many years and how many months and days, how all of those things are related to each other. So all dimensional analysis does is gives us a system for organizing those conversions, because as we work through this course, we're going to come across units of measurement that we may not be super familiar with in the process of learning chemistry. So the thing to remember about a conversion factor, it's just an equality that means 1, and we write them as fractions. So a couple examples of an equality: 1 foot contains 12 inches. And I can write that as a fraction. And if I write 1 foot over 12 inches, well, 1 foot is equal to 12 inches. So anything equal to itself written as a fraction is the same thing as saying 1. And it doesn't matter if I switch it to put 12 inches on top over 1 foot, that still just equals 1, because those are equivalent measures. I can do the same thing with a metric measurement. And if you recall back to the metric measurements, 1 meter is equivalent to 100 centimeters. So I again could write that as a fraction, where I put 1 meter over 100 centimeters, which equals 1. Or I could say 100 centimeters over 1 meter also equals 1. So these are conversion factors. And it's just two things in different units, two measurements that have different units, but they're equivalent to each other. If I took out a meter stick and counted the number of centimeters, it would have 100 centimeters to it. So those two things are equal to each other. Or a ruler that we're familiar with, 1 foot ruler, contains 12 inches. So if we're converting units, let's say we're not working with perfect conversions. Maybe I'll give you a measurement and you measure that it's 3.7 feet. And I say, well, I'd like for you to convert that to inches. Dimensional analysis is just a system of organization to help us make those conversions. And so the way we teach it here is to use what we call the train track system. So you just make like a little cross. And the first thing in the top left box is always going to be the number that you're given, including units. So that example that I said, I want you to convert 3.7 feet to inches, I would put that 3.7 feet here in this top left box. It's the number that I'm given, including units. And then in this next section, this is where I'm going to put one of those conversion factors. So a conversion factor goes here. And so hopefully you'll start to recognize that this just is a fraction. It's something over something else. So we did that up here. We wrote these as fractions. And I said that it doesn't really matter if you put one over the other because they're both equal to 1. Well, once you get down here to where you're actually trying to make conversions, it does matter which goes on top and which goes on bottom. And it's really, really easy to keep track. We want to put the unit that we want on top and the unit that we're given on bottom. So if I said I wanted to convert feet to inches, I'm starting with feet here, which means I'm going to put feet on the bottom. So whatever number in my conversion factor that has the same unit as the number I'm trying to convert has to go on the bottom. And the reason for that is those things are diagonal from each other, so they're going to cancel out. So we want to get rid of feet and cancel it out with feet on the bottom, and we're going to convert to whatever our wanted unit is on top. So that is just the general form for how you set up a dimensional analysis problem. So now let's actually try one. So here's a couple practice problems. If I have 72 inches and I want to know what that is in feet, I'll set up my train track. The number that I'm given is 72. So I put 72 with the unit. And then if I think back to my conversion factor up here, how feet are related to inches, 1 foot is equivalent to 12 inches. That's an equality. But I'm going to set that up as a fraction with the unit that matches what I was given on the bottom. So inches in my problem means I'm going to take inches in my conversion factor and put that on the bottom. And then whatever this is equivalent to will go on top. Because this component is just like saying 1. So when I multiply or divide or do any arithmetic, I'm not changing the fact that this is 72 inches. I'm just changing the unit. So inches will cancel inches because they are diagonal. And now the math. What the math looks like, anytime you see a vertical line, you should think multiplication. So I'm going to go 72 times 1. 72 times 1 because there's a vertical line separating them. Any horizontal line is division. So this is where division happens. So 72 times 1 divided by 12. And I plug that into my little calculator. And this comes out to be a perfect 6. The only unit that did not cancel was feet. So whatever you're left with in that top right box is going to be the unit that you're left with. And so we end up with 6 feet. And if you recall, sig figs, the number 72 has 2 sig figs in it. So this is 1, 2 sig figs. There's no zeros here that we have to consider. The number 6 only has 1 sig fig in it, which means we need to make an adjustment because our answer must match the same number of sig figs as our original question. So if I add a 0.0, that now makes my answer have 2 sig figs. So 72 inches is equivalent to 6.0 feet. That is how you do dimensional analysis. And I know that seems like a lot of work for something that should be pretty easy, but when we start using units that you're unfamiliar with, or units making a conversion between something where there's not a direct link, for example, inches to feet, we know that it's a 1 to 12 ratio. But what if I had asked you to convert inches to something like time, and there was multiple steps that we had to get through if we were talking about like a speed, like you can travel so many miles per hour or whatever like that. So how long would it take you to go 72 inches? So that takes multiple steps. And so the system of organization will become really important in examples like that. Let's do another one. So we got 12 meters and we want to know what that's equivalent to in centimeters. So I'll set up my train track, put the number that I'm given in the original problem, including its unit. Recall from the top that 1 meter is equivalent to 100 centimeters. I've got meters in my original question, so I need to make sure I put the meter component on the bottom. Well, 1 meter will go on the bottom here, and that's equal to 100 centimeters, which I'll put on the top. The unit meter cancels out. Anytime I see a vertical line, that's the same as multiplication. So here I have 12 times 100. The horizontal line means divide. So 12 times 100 divided by 1. So my answer would be 12 times 100 divided by 1, which is 1200, 1200. And the last unit that remained uncanceled was centimeters. So 1200 centimeters is equivalent to 12 meters, but I've successfully changed the unit. There's a note down here that says, if an answer doesn't come out to correct sig figs, put it into scientific notation. Now, we didn't need to do that here because we were able to add that 0. But in this one, let's put this into scientific notation because we need to ensure that this number has the appropriate number of sig figs that match the sig figs from my original problem. 12.0 contains 3 sig figs, the number 1, the number 2, and since this 0 is at the end of this number, it does count as a sig fig. So how do I get the number 1200 to contain 3 sig figs? Well, if I put it into scientific notation, which means I'm going to put the decimal, the imaginary decimal, I guess, is right here. I'm going to move it to make the beginning of this number fall somewhere between 1 and 9.999. So I'm going to move the decimal so that it's 1.2. But I want 3 sig figs, so I'm going to say 1.20. And then times 10 to the number of places that I had to move that decimal, which in this case was 3. So times 10 to the third power, and that is centimeters. So 12 meters is equal to 1200 centimeters, which is also equal to 1.20 times 10 to the third power centimeters. Great job. So let's try a couple together from this conversion practice page. All of these are unfamiliar units because they are completely made up. So a conversion factor of 1 zog equal to 2.9 who's, or 1 who is equal to 5 maybes, so on and so forth. So there's some up here. There's also some at the bottom of this page, some different conversion factors. So I'll do a couple of these and then you can complete the rest and then submit those to this assignment. So this first one, we want to convert zogs to bugs. And if you notice, there are no direct conversion factors that get us directly from zogs. Oh, I take that back. There it is right there. There's a zog directly related to a bug. One bug contains 3.7 zogs. So I'm going to say my original number with its unit, set up my train track. I'm going to put the unit that I start with on the bottom for my conversion factor, including its number. So I need zogs to go on the bottom. So it's 3.7 zogs. And 3.7 zogs is equal to 1 bug. The unit zogs cancel. Bugs is the right unit for what I'm trying to answer. So now I can just do the math. 3 times 1 divided by 3.7. And my calculator spits out a big long decimal, 0.81081008, yada, yada, yada. So we're going to pay attention to our sig figs. When in doubt, always go back to what the original question had to it. So this number has 2 sig figs, which means I'm going to make my answer to 2 sig figs. The first 2 digits are significant, and I don't need to worry about any rounding rules. So I'm going to say my answer is 0.81 with a unit, because numbers in chemistry make no sense unless you tell us what they are. So 0.81 bug. Let's try another one. So here we have 206 maybes, and we want to convert those to who's. And I check all my conversion factors. There's a direct link between who's and maybes. So 206 maybes. Convert. I'm going to put the maybes unit on the bottom. And here it's 5 maybes for every 1 who. 5 maybes on the bottom, because I need this to cancel. And that's equivalent to 1 who. Who's is what I'm trying to solve for. So I can finish and just do my math now. So 206 times 1 divided by 5, which is, my calculator says 41.2. This number has 1, 2, 3 sig figs to it. My original number has 1, 2, 3 sig figs. So I am good to go. And again, don't forget units. No naked numbers in chemistry. Let's try one that doesn't have a direct link. Let's skip and try number 4. So first off, do not be frightened off by the fact that this number is in scientific notation. It's not scary. It's just a number. I'm going to show you how to use your calculator so that you can type this in without any fear. We are going from zogs to maybes. And I don't have any conversion factors that connect zogs directly to maybes. But what I can do is I can take a zog, turn it into a who, and then I can take a who and turn it into a maybe. So that is a 2-step process. It's no big deal. So the process is the same. We start with the number that we're given in our top left portion of our train tracks. So 3.0 times 10 to the negative 3, and this is zogs. Let's set up a train track. I'm going to get rid of zogs, and I said I need to convert zogs to who's first, and then I'm going to take who's and convert them to maybes because I have a connection there. I have a conversion factor or an equality for that. So I'm going to get rid of my zogs, and that conversion was for every 1 zog, that is 2.9 who's. So that is me getting rid of zogs by canceling here and converting it to the unit of who's. But I don't want to stop in who's because I want to convert to maybes. So all you have to do is add another section to your train tracks. Add one more section to your train tracks. We're going to add another equality. So at this point, the unit that I have remaining is called who's. I need to get rid of who's because ultimately I'm trying to get this to be maybes. So looking back up here, 1 who is equal to 5 maybes. So I'm going to put that as a conversion factor with the unit I want to get rid of on the bottom and the unit I'm trying to get to on the top because who's can cancel who's here. Now the unit that's left uncanceled agrees with the unit that I am trying to solve for, which means I don't have to do anything else other than use my calculator. So again, anytime you see a vertical line, that means to multiply. And in this case, we're going to have 3 numbers to multiply instead of just 2. Anytime you have a horizontal line, that means to divide. So we're going to divide by this stuff on the bottom. Lucky us, everything on the bottom is a 1. So technically, we don't have to type those in our calculator because dividing a number by 1 isn't going to change the outcome. So for this particular question, we just need to multiply 3 times 10 to the negative third times 2.9 times 5. Now let me show you how to use your calculator for scientific notation. If you have a graphing calculator or just a regular scientific calculator, you should have some button on there. I'm sorry, it's a little blurry. That looks like that, like a double E. If you're using your phone, I'll show you this. Most phones, if you turn them into landscape, will have that double E button right there. That is the same thing as times 10 to some power. So when I want to type 3 times 10 to the negative third, I put in 3.0, and now I just need to tell it times 10, and it's going to wait for the power. Please do not use the multiplication button here because this is telling your calculator to do a math function. This is not a math function because this is just a number. So we're going to say second on this guy and then hit that little E button, and that calculator says 3.0E. So that E is this times 10, and now we need to tell it what the power is. So I put in negative 3. Make sure that you're being very careful about that negative sign, that you're not using a minus sign or a subtraction. So don't use the math function subtract. Make sure you use the negative sign button. Now, we don't want to put enter because this is the same thing as just typing in a number. This isn't like I haven't told my calculator to multiply, divide, anything. So I'm not going to hit equal yet. This is just this number, 3 times 10 to the negative third. Next thing I'm going to do is multiply by 2.9. So just times 2.9, and then multiply by that last digit, times 5. Times 5. I don't have to divide by anything on the bottom because those are just ones. They're not going to change the outcome of my answer. I hit enter, and it gives me a result. So I want to make this number match the sig figs of my original number. This 3.0 times 10 to the negative 3 has 2 sig figs to it. So I'm going to round this answer to 2 sig figs, keeping in mind that zeros at the beginning are not significant. So my answer is going to be 0.04. The second sig fig is 3. However, the next digit over is a 5, which causes it to round. So I'm going to say my answer is 0.044 because I rounded that 3 up. And then the last unit that was left uncanceled is a maybe. And that is the answer. So please try and finish the rest of this on your own. Log into the tutoring hours if you have questions, or come see your teacher before or after school during their tutoring times if you have questions or you get stuck. And we look forward to seeing you next time.